in 2020, Renishaw set out to improve how they manufactured a family of complex parts.
Yeah, they were looking for an opportunity to reduce the manufacturing cost and enable a process that could be scaled for future demand and flexibility.
But it wasn't as simple as buying a new machine. Productivity pressures meant something smarter had to be engineered. Fast forward to today, and the answer is right behind us.
It certainly is, in the form of lots of high-performing sliding head machines, combined with data-driven automation and part measurement, all working together thanks to a partnership between Renishaw and Star GB.
Welcome to Renishaw Miskin.
So it's clear what we wanted to achieve in terms of we had a challenge to manufacture this range of products in a cost-effective way. So that was clear. How we were going to do it was not so clear. So the first obstacle for us was to pick the right machine tool, in terms of what sort of process is going to give us the right machining output, and being able to actually make the parts. And that's something we explored early with Star, and Star were able to produce some parts for us to give us the confidence that it could be manufactured on that platform. Beyond that, we knew that we had some challenges in terms of the responsibilities the operator would have to keep this process running. And then the introduction of the Renishaw Equator, the central product, was very much a collaboration, Star, Renishaw working together to make a process that gave us everything we wanted and was reliable.
Alec, clearly an amazing engineering solutions that you guys have developed, so well done.
Thank you.
But what's the benefit to Renishaw?
I guess the biggest benefit is the efficiency of this process compared to the previous process. The way they manufactured these parts previously was on VMCs, lots of in-process gauging. So now with the Equator system, we've transferred that to post-process gauging, which has obviously given us some massive saving on cycle time.
Let's have a look at the all-important component, because this is pretty impressive.
Thank you. So yeah, from inch and 5/8 bar stock, 6082 aluminium. Believe it or not, there's over 200 dimensions that we have to adhere to for this particular component. So really, really complex.
And why was the SX38 selected as a machine by yourselves?
Obviously we needed a large amount of tools, large amount of offsets obviously. It's our flagship machine, go-to machine really for really, really complicated parts, but it's ideal for these small prismatic parts.
And it's not the only part that we're making as well, or you're making. I mean, if you take this two here, what's the difference?
Okay, so there's three stages. There's a setting block stage where we set up the primary datums for the machine. Then there's a setting piece that we measure. So when we're measuring this particular component, we're measuring all the roughing tools as well as the finishing tools and firing those offsets back into the machine tool.
So you essentially use machining that instead of machining the first off of a batch, and you're then reporting all that information back into here to make sure the future components are perfect.
That's correct. We've even got a binary code system, dot matrix system on the side of the component, so the Equator knows exactly which machine tool it's come from, so it knows exactly which machine to fire the offsets back to.
And I even heard Renishaw saying that, kind of changing things on the machine, they used to spend an hour per shift, and that's now down to about 7 minutes.
Like I say, loads of efficiency savings, but it's really, really good process control.
But I also want to know how you get the information from the Equator into the machine.
Okay, so we've got a binary system where we manufacture some dots onto the component. The Equator measures where those dots are, so it knows exactly which machine tool the particular part has come from, and that's the machine tool it fires the offsets back.
Well, so this sounds like a bit of a triangle to me. You've got the Star sliding head lathe, the Equator machine, and then Renishaw Central.
It's total process control.
So James, we're here on the shop floor. Can you tell me what your role is as part of this project then?
Sure, yes. I look after the Renishaw Central team, and they develop the data automation aspect of this project.
So what's the difference between data automation and physical automation then?
Yeah, so these machines all have physical automation. So in these cases, it would be bar feeders, automatic unloading, and the data automation element is measurements made here on the Renishaw Equator gauge and sending back to the machine updating tool offsets. So that helps us to both set up the process and keep the process in control.
And then how do they all interact between one another then?
Yeah. So the Equators and the CNC machines are all connected over the network to the Renishaw Central server. And any measurements made on the Equator here, Renishaw Central makes offset calculations and then can send it back over the network to the machine's control. As you can imagine, these machines are pretty complicated. The parts that they're producing are quite complicated. We've got 12 axes on these machines, as you say, up to 73 tool offsets. So anybody who's set up sliding head machines will know that it is a long task. So traditionally, for a complete breakdown and rebuild of the process for a new part, it was taking us over a shift to get that set up. And now we're down to less than 70 minutes for setting up a whole new set of tooling.
So what do you think this has ultimately done then for the whole project, having all of the systems interacting with one another?
Yeah, so with the physical automation, we've got the loading of the material, and then we've got this for setting up the workpiece. So in terms of metrics or ROI, as I said, we've gone down from a little over a shift to set a part up, set new tooling up to being about 70 minutes, but also the operator intervention. So previously it was about an hour a shift, just keeping the process tweaked, and a skilled operation, that is, and now we're down to between 7 and 10 minutes a shift.
And in terms of all of these machines, how many operators are working? You know,
you can take a look up and down. We've got one guy running this line here.
It's phenomenal.
Yeah, and you can see a lot of green lights. So,
where have you seen the biggest improvements then from implementing a project like this?
I mean, the biggest improvements really, we've achieved our cost reduction targets that we had, so that's a big improvement. We've also introduced a platform that is scalable. We're not looking at highly customised machine tools, ancillary processes. It's standard equipment, and it's something we can scale up as the business continues to grow. So that is important to us. We see that as a major success, and it was very much a collaboration. So, Star, Renishaw working together to make a process that gave us everything we wanted and was reliable.